class. Today we're going to be doing our last lesson of 9.1. So this is our 5th day, and today we're going to be looking at how do we simplify cube roots. Cube roots are really important because you're going to get into volume, okay? And then this is going to be our last lesson for 9.1. So today with looking at cubes, I want you to think about what are the 10 first perfect cubes. So think about like one cube, just like we did with squares. Now, one cubed isn't really going to help us, but I just want you to kind of start from the beginning. So one cubed would be 1, and then 2 cubed, so 2 times 2 times 2 would give us 8. And I want you to keep going or think about all the way up to 10 cubed, okay? So 3 cubed, 3 times 3 times 3 would be 27. Now, I know this can get kind of big once you start getting up into like 5s and 6 and stuff like that. So I'm going to show you in my calculator here. Remember we did this before. We went to our y equals and then we typed in x squared. This time let's go x cubed. So I'm going to go x, and then honestly it's easiest if you just use this caret key right here. That's pronounced as the caret key. So raised to the 3rd. Now, I know there is a cube key under the math feature, which is number 3 as well. But honestly, it probably just as fast to use it on the outside. So once you have x cubed typed in, you want to go to your table. So it's right above the word graph. So we're going to go second graph. And this is going to bring up our list of cubes. And so let me just kind of adjust my chart here. So look at 1 cubed, 2 cubed, 3 cubed, 4 cubed. Okay, so why don't we go ahead and just let's write the rest of these down. So we've got 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and 10 cubed. Okay, so if you want to write the numbers down above it, you can. You might not even need to write the little cube if you just want to say 6, 7, 8, 9, 10. That way, if you see this number, like look right there, do you see 216? You go to your chart and you're like, oh yeah, that's pretty quick. So sometimes the little numbers above it are helpful, okay? So again, what I like to sometimes do is if I was starting an assignment or something, I would write these on the top of my paper. Or if you have an index card, you know, if you could take like a little index card, you could put the perfect squares on the front, and then you could put the cubes, or you could put the cubes on the back. Something like that would be really helpful, okay? So what we're going to do is the same thing that we did. It was square roots, only now we're looking at cubes, okay? So 135. If you think about 135, 135 falls right here, okay? So we need the numbers that are smaller than 135. I don't think it's going to be divisible by 125 because it's too close together, but we can go ahead and just start there. So we're going to take our number, which is 135, and we're going to see which one of these go in. So we would divide it by 125, and we were like, nope. So then we move to the next one. So we go 135 divided by 64. Nope. 135 divided by 27. Look at that. Now, if you knew that combination off the top of your head, you would not need to try it in your calculator. But I don't think very many people know these larger numbers with multiplication. So we're going to use this as 27 times 5. And so if we take the cube root of 27, we just get 3. Okay? So the cube root of 27 comes out as just 3. And then the cube root of 5, like watch if I go the cube root of 5, look at how ugly that is, okay? So we're going to leave the cube root of 5 alone, and then there is our answer. So this is very similar to what we were doing in the day 1 with square roots, only now we're doing cubes. And if I didn't mention this before, let me grab a sheet of paper here. A perfect cube. So if you think about the cube root of 8, that's really made up of 2 times 2 times 2. So see how there's 3 of them. You see the little 3? There's 3 of them. That's why 1 comes out, and there's basically nothing left over. So it's very similar if you were to take the square root of 4. The square root of 4 is 2 times 2. Now, when you take the square root, there is a little 2 sitting right there. It's just so common that many people don't write it. It's exactly the same as when you first learned with variables and you might have had a problem that looked like this. And in the beginning, you might have said 1x. And then now that you've been dealing with these a long time, you don't put the 1 there anymore. Square roots are the same. We just don't put that little 2 there because they're so common. But we do need it with the cube. And it's supposed to go in between the little check mark thing. So it kind of is small and it's in between there. We don't want to write it out front because that means 3 times. So we want to make sure that we're putting it in the right location, okay? So let's take a look at the next one. Let me just erase this. So 729, you go to your list here and you're like, oh, sweet, it's right there. So the cube root of 729 is just 9. There is no more radical left over, okay? So now the next one, we're going to look at 216. So we do the same thing. We start up here and we're like, go through. Oh, there it is. So 216. So this is perfect. So the cube root of 216 is just 6. But now we're going to have to deal with this variable, all right? So I want you to think about that. There's 4 of them. So if we have a group of 3, one of them gets to come out. So out of this group, 1 comes out. Now notice this is left over, and so it must stay underneath. And then this would be our final answer. So it's really similar to what you did with the square roots, only now we're just looking for groups of 3, okay? So notice we have 3 more problems here, which are very similar to the ones we've, just did above. They just all have variables. So if you want to pause the video and try these on your own, I think it would be really good practice. Our last 2 at the bottom here are multiplication. So maybe just kind of wait on those for a second. But again, if you'd like to pause it, you are welcome to try these. Okay, hopefully you gave these a try. For 192, the combination that I found to use would be 64 times 3. So if I take the cube root of 64 from my list up here, that would be a 4. Now, if you're wondering, sorry, I kind of skipped it. If you're wondering how did I get this combination, what I would do in my calculator is I would take 192 and I would go up to this list and I would see where 192 falls. So it falls right here. So then you start with the numbers smaller. So I would divide by 125, and then I would just keep going. 192 divided by 64. And notice once I get it. Once you get a combination, you want to stop. If you tried to use 8, we talked about this in a previous lesson. This is going to give you a problem because you have another number inside here. So I always recommend starting with the largest ones and working your way down. So don't go small up. Make sure you go largest down. That really will save you some time. So we've got the cube root of 64, which is just 4. And now I'm going to leave a little space here. And so I have this 3 left over. So that's going to stay under. And then I have z to the 5th. So again, if you think about z to the 5th, there's 5 of them, correct? Every time you get a group of 3, they get to come out of the radical. So you've got this group, and it only comes out as 1. So it's like 1 of those comes out. And then you have these 2 left over, but they don't have a third person. They don't have a third group. So they need to stay under, okay? So that would be what our variables would look like. So if I just go back to my paper here, I've got a z on the outside and I've got a z squared under. Now remember, the graphing calculator cannot check the variables for you. It doesn't understand that. But we can check the numbers. So if we want to get the cube root, we just have to go to the math feature and we go down to the cube root and we can type in 192. And then if we want to type in our answer, we type the 4 first, and then we do the cube root of 3. And then notice our numbers are the same, so we know we have reduced them correctly. Okay? All right, number 5. Number 5, I used 1,000 times 9. Now you got to be careful on this because your brain interprets this as a perfect square, but it is not a perfect cube. Okay, so be careful. So the cube root of 1,000 is just 10. Again, I'm going to leave a little space here, and then the 9 is stuck under. Because remember, the 9 is only made up of 3 times 3, so it doesn't have enough to come out. So the 9 is going to be stuck. And now you want to think about x to the 14. So I don't know if you really want me to write out 14 of these, but just kind of think about dividing by 3. So if we were divided by 3, that means we would get 4 groups. Because 4 times 3 is 12, right? So we would have 4 groups of 3, which gives us 12. And then if we go 14 minus 12, that means there's 2 left. So in a way, this is kind of a bit of a story problem without all the words. So you have to think about how many groups do I have in that. But if it helps you, go ahead and draw them all out. Draw out 14 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I hope I counted out right, 14. And then every time you have a group of 3, you could kind of circle it. So notice I have 1, 2, 3, 4 groups, and notice I have 2 left over. Okay, so if it helps you, just grab a scrap sheet of paper and draw these guys out and circle the groups. So I had 4 groups come out and I had 2 left over. And then that would be my final answer. Okay, remember, cubes are really common in volume, so that's why we're practicing them right now for when you guys go to geometry and your teacher asks you for like the volume of a prism or the volume of a cylinder, that you know what to do. Okay, so for 56, I was going to use 8 times 7. Now that one you might have known off the top of your head, but if you didn't, let me just show you on our chart up here. So for 56 would go right here. So that's where 56 is. So I would go 56 divided by 27. Oh, so 56 divided by 8. And there I've got it, okay? So now the cube root of 8 is just 2. And then I can't do anything with the 7, so I'm going to leave it under. And now let's look at our variables. This time we have 2 different sets. So let's look at our x's. We have x to the 9. So x to the 9. If we divide that by 3, that's just 3 groups. And there's no decimal. So then this would come out as x cubed. Sorry, I didn't leave myself a lot of space here. Let me see if I can maybe just shorten up my radical symbol like this. Just kind of make it open. Scooch it over just a little bit. I didn't leave myself enough space for 2 variables. So I've got x cubed. And now let's do the y's. So I have y to the 11. So y to the 11 divided by 3. Basically, 3 is going to go in there 3 times, right? Because 3 times 3 would give me a 9. What's 11 minus 9? 2 left. Okay, so this is how many are left. And again, if that is difficult for you, grab your piece of paper and just draw out 11 of them. You know what I mean? Just write them out, and every time you get a group of 3, circle it. And then your next ones, circle it. Okay, and then see how many are left over. So I'm going to have 3 groups out, and I'm going to have 2 that were left over when I did my division. And then this is my answer. Again, you can check the number, so I can check the cube root of 56. I know my numbers are right, but there's no way for me to check my variables. Okay, so that one you just almost have to wait and get some feedback from the teacher. So that is just simplifying. Now the last part of this lesson is multiplication. We don't see a lot of foiling with cubes, and so we thought we would just practice the distributive property, okay? So what we've got here is the cube root of 7 times this binomial. So what we're going to do is we're just going to distribute, okay? Now I don't know this number off the top of my head, so I'm just going to use my calculator. So 7 times 54 is the cube root of 378, and then I'm going to take and distribute it again. Now remember, there is a 1 out front here. So it's 1 times 11, and then square root of 7 times square root of 2, or sorry, cube root, sorry, not square, cube root. And so I get a 14. Now, I know that 14 cannot go any lower because 14 is only divisible by either 1 and 14 or 2 and 7. And neither of those are perfect cubes. So I know this one is done. I know there's nothing to do here. So this one, done. But I'm kind of not sure about this one, the 378. So let's take our calculator. And 378 is going to fall right here. I highly doubt it's divisible by 343 because it's just too close together, but you can always give it a try. So now we're going to go 378 divided by 216. And then we just keep marching our way down. Whoops. 378 divided by 125. 378 divided by 64. Gosh, kind of get like, oh, I wonder if I'm going to even hit something. But you just got to be patient and notice you'll get it. So this is going to be 27 times 14. So what is the cube root of 27? So the cube root of 27 is just 3, okay? And then I have cube roots of the 14, which is left. So that is just if I were to reduce this down. So those are equivalent, okay? Now, if you notice, look at the piece underneath. Do you see how they're both a 14? So because the radical pieces are the same, we can add the coefficients. So we can go 3 plus 11, and then cube roots of 14. And these numbers are just a coincidence. It doesn't mean anything. Now, trying to type this into your calculator, you can do, but for those of you who have the older style calculator, so when you do the cube root, like when you do this cube root, if yours puts a parenthesis here, trying to type this original in might be a little bit complicated because you're going to have to make sure you're closing off the parentheses. Now, if you notice on my calculator, whoops, went like that. Okay, so on my calculator, notice mine does not put the parentheses, so it's a little bit easier to test it. So there's the original. And then our answer was 14 cube roots of 14. And so I know I've got them right, okay? But again, sometimes the way these are written, you just have to be, the way the calculator functions, you got to be careful with those parentheses. So we only have one more problem left. So if you'd like to give this one a try on your own, this is the cube root of 2, and then this is the cube root of 108 plus the cube root of 135. Again, we only have additions and subtractions here, is no division. But go ahead and pause it and try it if you'd like. Okay, so hopefully you tried it. Why don't I just I'll tell you the answer and then I'll also work it out as well. So the answer is 6 plus 3 cube roots of 10. So if you got that answer, feel free to stop here and move on. This is our last lesson for 9-1, so go ahead and try a few practice problems and take that exit quiz. All right, for those of you who need a little bit more help, let's go ahead and distribute. So we're going to go 2 times 108, which is 216, and then 2 times 135, and that's going to be 270. Whoa, both of these are pretty big, huh? See, over here, I knew the 14 was only made up of 2 times 7 or 1 times 14, so I knew it wasn't going to work. But both of these are kind of big. So let's take 216 and let's go up to our list. Wait a minute. There's 216 right there. So this one must be perfect. So 216 just works out to be plain old 6. Like there is no more radical because it's a perfect cube. And so even if I tested in my calculator here, math, cube root of 216, do you see how the radical is gone? Okay, so that's kind of a nice one. All right, let's do the 270. So 270, I'm going to go up to my list, and I'm not quite as lucky on this one. 270 falls right here. So I highly doubt 270 is divisible by 216 because they're just too close together. But we can always try it. All right, 270 divided by 125. 270 divided by 64. See how I'm just marching my way down the list? 270. Now you should know this one. It's got to be divisible by 27 because all you have to do is add that extra 10 on. So it's 27 times 10. That would be our multiplication, is 27 times 10. 27 is the perfect cube. So the cube root of 27 is 3. I can't do anything with this plus 10, so I just leave it, cube root of 10. And then I have a plus sign in the middle. And so this would be my final answer. Now I cannot put those together because of this doesn't have a radical. Okay, you can only put them together if it has a radical. Now if you want to put the radical first, that's fine. It really doesn't matter the order, okay? So that concludes our 9-1. All of our 9-1 is now done, okay? So go ahead and practice the problems and take your exit quiz.